Now let's just move on further towards the question number 3, which says how many silver coins 1.75 centimeter in diameter and of the thickness 2 mm must be melted to form a cuboid. So actually the silver coins are getting melted to form a cuboid of the dimension 2.5 centimeter, 10 centimeter and 3.5 centimeter. It means that if we are just talking about the total volume of the silver coins, then they should be is equal to the volume of the cuboid having the dimensions as 5.5, 10 and 3.5 centimeter. So it means we are here talking about the number of the coins, volumes, and we are converting that into the volume of a cuboid. So we are converting them into a cuboid. So let's just find out the volume of all. So first of all, as you can see over here, we are converting the number of coins. We are converting the number of coins into a particular cuboid, and thus we just have to find out how many number coins are melted to form a cuboid of the dimension this. So let us suppose according to the question, I'm just saying according to the question, let n be the number of coin, let n be the number of coin, let n be the number of silver coins. Then according to the question, n into volume of one single coin is actually is equal to the volume of cuboid. So according to the question, it is given to us that n into the volume of one single coin should be equal to the volume of cuboid. So let's just apply this particular thing onto the question. So first of all, let us suppose we are just finding out the volume of one single coin. So as you can see, volume of one single coin is just as similar as that of finding out the volume of a cylinder, because if we are just talking about a particular coin, then we consider it as nothing but a cylinder. So it implies that the volume of one single coin is nothing but is equal to the volume of cylinder. It is nothing but equal to the volume of the cylinder, and this is nothing but is equal to pi r square h. Now let's just talk about the radius and the height. So according to the question, it is already given to us that the silver coins are 1.7 centimeter in diameter. So it is given to us that the diameter of this particular coin is actually nothing but 1.7 centimeter, 1.75 centimeter. This is 1.75 centimeter. So it means that the radius is nothing but is equal to the half of diameter, that is 1.75 divided by 2 centimeter, and further it is given to us that its thickness is actually 2 mm. So thickness means its height is given to us. So thickness is nothing but is the same as that of the height, which is nothing but is equal to 2 mm. So let's just convert it into the centimeter. So we know that in 1 mm we have 0.1 centimeter. So this is nothing but 2 by 10 centimeter. This is 2 by 10 centimeter. So now let's just plug in all the values over here. So we have this as nothing but pi r square h. So let us suppose if I'm just taking pi as 22 by 7 over here, and we have r square, and r square is nothing but 1.75 divided by 2 whole square, and the height is nothing but 2 by 10. Which I am taking as nothing but 1 by 5. So this is nothing but the volume of one single coin. Now let's just plug in it into this particular condition. So let us suppose if I am just taking this equation as nothing but 1, I am considering it as the equation number 1. Now let's just plug in all the values over here. So let us suppose if I am just starting with the condition from equation number 1, we can write n into volume of one single coin. Volume of one single coin is nothing but 22 by 7 into 175 divided by 200 into 175 divided by 200, which is into 1 by 5, which is nothing but is equal to the volume of the cuboid. We know that the volume of cuboid is actually nothing but is equal to L into B into H, L into B into H, where length is given to us as 5.5 centimeter, breadth is given to us as 10 centimeter, centimeter and height is given to us as nothing but 3.5 centimeter. So let's just plug in all the values over here. So we have L as nothing but 5.5 into 10 into 3.5. So we just have to find out the value of N. So let us suppose if we are just sorting it out. So first of all, we have this 5. Let us suppose if I am solving the values over here first rather than going over there. So as you can see, we have this value as nothing but 7. So we have 7 and 7 into 2 is 14. So we have 3 remainder and 7 and 5 is nothing but 35. Again, we can take it as nothing but 25, and we have further 5 and 5 is nothing but 25. So 5 and 4 is 20 and 0. Further we have the values as nothing but 2 and 1 and 1, 2 and 2 is 4 and it is 0. Further we have the values as nothing but 5, and we have 5 and 3 is nothing but 15, and this is 5 again, and 5 and 4 is 20. So further we can sort it out as 5 into 7 is 35, 5 into 4 is 20, and we have this value as 0. So at the end we are actually getting the values as N into 77 divided by 160, which is nothing but is equal to 55 divided by 10 into 10 into 35 divided by 10. So as you can see, 10 and 10 are getting cancelled with each other. So let's just calculate the value of N. So we have the value of N as 55 into 35 divided by 10 into 160 divided by 77. So 11 into 5 is 55, 11 into 7 is nothing but 77, 7 and 5 is nothing but 35, and then we have 0 and 0 get cancelled with each other. So at the end we are getting N as nothing but 25 into 16. We are getting the value as N is 25 into 16, and when we will multiply it, as you can see, we just have to find the number of the coins. When we will just multiply it, we will get the answer as nothing but is equal to 400, as 400. So hence it implies that the number of the coins are nothing but is equal to 400, because we have taken N as nothing but the number of the silver coins. So the number of the silver coins are nothing but is equal to 400, which is nothing but our answer for this particular question.